team. Thank you. So let us officially begin our day 2 for international conference ICCMES 2024. Yesterday, we had a wonderful response from our participants. Almost all of the papers which were scheduled in the technical sessions were present, except 2 papers which were absent. And for that, we have again rescheduled those 2 papers who could not be presented yesterday due to certain technical issues or certain problems from the author's end. Those are rescheduled today, and hopefully in our sessions, technical sessions 3A, 3B, 3C, which will be starting from 10:30, they will be scheduled by then. So with this note, let me introduce our guest speaker for today, Dr. Kishant Kumar. He is an assistant professor at IIT Ropar, and he will be presenting his keynote speech on gas separation and storage for environmental and energy concerns. Dr. Kishant Kumar is a chemical engineer, and he was graduated from Birsa Institute of Technology, Sindri in 2009. He completed postgraduate in 2012 and doctorate studies in 2018 from Indian Institute of Technology, Guwahati. He has worked as a postdoctoral fellow in Indian Institute of Sciences, Bangalore. He has worked till July 2022 as an assistant professor at NIT Warangal, and currently he is working as an assistant professor at IIT Ropar. So with this brief remark about Dr. Kishant Kumar, I will ask him to please join the podium and please take over the session. A very warm welcome, sir.
Thank you, Tanmayji, for the nice introduction. Good morning, everyone. And first of all, I would like to thank the team of ICCMES 2024 for inviting me here in this conference.
It's a pleasure, sir.
So yeah, so may I request you to may
Yes,
I share
please.
my screen?
Yes,
now,
please.
Yeah. Yeah. So
yes, sir, we are able to see your screen. If
yes,
it can be made in full screen mode, that will be much
yes.
better.
So now is it in the full screen mode?
Maybe for you, sir, we are able to see only your slides and with the presenter. If you can present, if you can push on present now and then present entire screen, then whatever you will be displayed on your screen,
Now,
we will be able to see that.
The full screen?
No, sir. We are only able to see. You might have shared only the PPT screen, so that's why it is not coming full screen to us. You can again go to Google Meet and press on present now, and then present your entire screen.
Yeah.
Then when you will do full screen, we'll be able to see that full screen.
Can you see now? It is okay?
No, sir, still it is in the same mode. You have to stop presenting once.
Okay.
Now again, you can go to present now and then share entire screen. Yes, sir. Now you can go to your PPT and make it full screen.
Is it now okay? This one is okay now?
This one, we are able to see your whole screen now. You can go, you can make it full screen. Once you make it full screen, I hope you will be able to see that.
Actually, here I can see the full screen, but other side.
Still.
Okay. Let me check.
All right, sir. Otherwise, you can make it maximized, and then whatever, however best we are able to see, we'll go ahead with that.
Yeah. Is this okay? Let me check view.
I meant so what you are able to see on your screen currently?
I'm able to see my full screen here. Like if
You can press escape once. You can come out of the full screen.
can you see the menu over the top panel?
We are able to see your desktop
Uh,
screen, and on that
so
your
here we have a
PPT is
play button,
open.
right? Play.
Yes, sir. We are not able to see that because it's on. You are working on Mac, so it is not giving us the access to the full screen currently.
Okay.
That is not presented to us. You can maybe maximize just your PPT. You can come out of full screen. You can maximize your PPT
Yeah.
there itself.
It is maximized only, but I don't know how much part you can see.
Then previously it was better than if it is
Okay.
this way. Then last you were presenting only that particular window. You can go to that particular window and present that. Maybe on Meet you can go back once.
Right.
Now you can again present, stop presenting and present something else. You can do that otherwise, or you can present, and now you can present the PPT screen only.
Is it now okay?
Okay, sir, and this much, this will work out. Please, sir, we can start.
Okay. Uh, think, okay. So, thank you, everyone. So, uh, myself, no, I am working as assistant professor in the Department of Chemical Engineering at IIT Ropar. So today I will try to introduce the computational methods used in various science and engineering fields to investigate or uh, perform or to explore the understanding of phenomenons like any natural phenomena like adsorption or absorption or any biological activities or any kind of energy or environment no phenomenons you can see at atomic level, and you can have some better understanding how it's happening at atomic scale. And we will also see how we can correlate it with the experiments. So today we will just discuss a material that is a silica material, which is widely used in industry. And apart from that, I will also discuss metal organic framework, which is also of industrial applications for energy and requirement. And then we will see one another application that's called absorption, that how one can separate gas for different applications using liquid systems. Another example I will take for the diesel oil, in which if you have several impurities, nitrogenous impurities, how you can separate those impurities prior to bringing into the market. And another is the ongoing work, which we will discuss, like recycling the spent lithium ion battery, how one can recycle those valuable elements after the end of the use of such no valuable batteries.
Slides are not moving if you are
Slides are visible.
visible, but they are not moving to us.
The second slide you are not able to see.
No, sir, we are only able to see your front page.
Only front page, but
Yes, sir.
I'm at the second slide. Okay, wait. What I can do? can make PDF. I can make then. I made the PDF now,
All
so
right, sir.
I can go with the PDF. Can you see the now PDF?
So you have to present it
Yeah.
on Google
Now,
Meet. You can go to
now
present something else. On present now, you can go to present something else.
okay.
Now you can choose window. Window you can
Entire
choose.
screen is okay.
Entire screen is also okay.
Yeah.
Now you can go to search your PDF.
This is the PDF. Can you see now?
Yes, so you can try to move it.
Yeah. It is in the full
In the
mode now.
second, now you can go to third. Maybe we'll see if it.
Third
Yes, sir.
is,
Now it is great. It is in full screen mode also,
yeah.
so it is
Yeah.
much better.
Okay. Okay. Thanks.
Yes.
So we will discuss about the mesoporous silica material, and we will discuss about metal organic frameworks, and then we will discuss about the gas absorption part, and also we will see the diesel oil having nitrogenous impurities in it. Prior to bringing into the market, we should remove those nitrogenous impurities from diesel oil. And another example from the experiment I will take, that is for recycling of spent lithium ion battery. Okay. So, and also I will discuss the ongoing research projects. So this I'm working in like areas called, that's porous material, gas separation using green solvent, gas separation using porous material, recycling of lithium ion battery, hydrogen storage also I am working on. So we will discuss, try to discuss within our given time. And let's discuss first about the mesoporous silica material. That's one material called MCM41, which is a class of material in silica, that's called silica mesoporous material. So the basically the pore size of these material are between 20 to 30 angstrom. So it's greater than your microporous material. So it comes under mesoporous scale. So it's called mesoporous material. So you can see this image here, over here. Can you see my cursor here? Can you
Yes,
see
sir. We
cursor?
are able to see, sir.
So this is the real experiment. So tame image of the real experiment. So you can see here the pores are glowing in a fashion. It's arrayed in a like honeycomb structure. So one pore is surrounded by 6 pore, you can see over here. So the same and these material are made up of silica material having silicon and oxygen linkages, and it has a good high surface area and the pore volume. So that high surface area and the pore volume we can utilize for several energy and environmental applications. So one is your gas separation, another could be your drug delivery application, another could be your gas storage. So there are endless kind of can be, it can also be used for catalysis purpose. uh, so in order to understand these material, we try to develop the model which can give us insight that how this material behaves when you impose or when you try to put some guest molecule inside this. So we try to develop a atomistic model, complete atomistic model, which you can see in the model 1. And when you replicate this model 1, you will get this picture, and which is really a replica of this tame image. So we started this model from a very basic unit cell structure. So that unit cell we have obtained from the experimental data, and that experimental data we have tried to model into the computer, and then we end up with this model. Now, in this material, we try to impregnate or incorporate ionic liquids. So once we have incorporated ionic liquid, then the activity of these uh, materials is enhanced. So for what it is enhanced, so I'm going to discuss in next slides. So you can see that prince your pristine mesoporous material is having a surface area of this, but can you see that when you have loaded this ionic liquid inside the pores of this, the surface area really enhanced, and you can see over here. And upon impregnation of more ionic liquid, we observe a significant decrease in the surface area, as expected, because we are intentionally hindering the available surface area of pristine MCM4 by introducing your ionic liquid. So that's why it is decreased. Okay. We are on the slide 7. Is it visible to all?
Yes, sir.
Okay. So now in this material, we try to see how this material can be used to separate CO2 from CO2N2 mixture, which is a combination of flue gas coming out from the power plants, CO2 and N2 mixture. So we try to see the first, the absorption of CO2 inside such material. Okay, so we have also after development of those atomistic model on the computer itself, we have tested our adsorption loading. So we have introduced CO2 at some temperature and pressure condition. So I will give some time, like 10 minutes, for as per your time availability. I will give time for you all audiences to ask your queries or question, so that
Sure, sir.
you can also understand, or you can also
We are
do such
encouraging
kind
over
of.
here, participants can write their questions in
Yeah.
chat box so that at the end
Yes.
it can be taken, so utilize the time.
Yes.
You can
So
please go ahead, sir.
audience can also study at their own computer or desktop, whatever they can use. They can do such kind of simulation there also,
Correct.
or they can at least start. So here, we have tried CO2 adsorption in such mesoporous material, and these loading with respect to pressure, which is benchmarked or tested with the real experiment also, and we observed a good match between the experiment and our developed model. Okay, so we have developed the model, we have we have calculated the CO2 loading inside our model, and the model giving the best match with the real experiment. So in this way, we validate our model, that our model is accurate, which mimics the result of the real experiment. So we can see here, upon impregnation of 16 pair of ionic liquid inside the mesoporous material, which was really giving a high surface area over here. So since this is a CO2 absorption is a surface phenomena, it's a physisorption process. So we can expect a higher loading compared to this pristine and the 13 loading. So this is the IL2 is the higher loaded ionic liquid, which have a lower surface area, and MCM41 is also having a lower surface area. but this red one is having the higher surface area with at 16 pair of ionic liquid. So we can see a higher loading because of the higher surface area. So you can from this kind of simulation, this is Monte Carlo simulation. So I also work on molecular dynamics simulation, Monte Carlo simulation. So this is Monte Carlo simulation which works on probabilistic approach. So here you can see in this kind of simulations like Monte Carlo and molecular dynamics or DFT, you can see real atoms and molecules on computer, and you can explore or you can understand the real phenomena happening at atomic level, which you cannot see from the experiment. In experiment you can just predict something, or you can just propose some theory, but from here you can see real atom and the molecules moving and interacting with each other. So here I introduced the blue one is your nitrogen, and this is your carbon dioxide. So I introduced in the ratio of 15 to 85 ratio of CO2N2, and at a temperature of 298 Kelvin, okay, at 12 bar. So at a elevated pressure, I have tried to show you that how these molecules are accommodating in the pores of the material. Okay. Now we are also interested, apart from the adsorption, we are interested or we should be interested in the selectivity. How the selective your material is towards one gas over another gas. So that is also one of the most important parameter while designing a adsorbent. Okay. Or any kind of separation if you are trying to approach for it. So you should be careful with this parameter, that selectivity of the one component over other should be high. Like here we are interested to remove CO2 from the CO2N2 mixture, so selectivity of the CO2 should be higher with respect to CO2, with respect to N2. So you can see over here that this even the red one performed better in terms of the loading, but in terms of the selectivity, it outperforms, and it underperforms the highly loaded material. So here you can see that IL2 is performing better in terms of the selectivity at low pressure. Okay. So this is for selectivity of CO2 over N2. This is for the selectivity of CO2 over CH4. Okay. So this actually I will most of the audiences are from the civil department, I think. Am I right? So
yes sir, yes sir.
yes. So this I like to know in your knowledge, I like to I want to just to say that this model, the people, the faculty from MIT, they have from the civil engineering department, they have worked on this model, and we try to replicate that model from their model actually. So for faculty from the civil engineering department, I don't know exactly his name right now, but I followed his paper. It was like 1990s they worked on these models. Yes. Now this is for CO2, selectivity of CO2 over CH4, which is kind of its application is natural gas sweetening process. In natural gas sweetening process, the primary gas is your methane. So what happens that there you have percentage of or impurities of CO2. So you need to separate or remove those CO2 prior to bringing it into the market. So you need some kind of novel adsorbent which can do this kind of job. Then your calorific value of this natural gas gets enhanced after removing the CO2. And also it's corrosion. Because of this corrosion issue in pipelines, you need to remove CO2. Now we will see the metal organic frameworks. So metal organic frameworks are the most no highly porous material in the world known so far. Okay, so this metal organic framework can have the surface area more than 15,000 meter square per gram. Okay, so it's huge when you are trying to no utilize the surface. So in 1 gram you can imagine a surface area of 1500 meter square. The study of the MOF is very important, and understanding of MOF at atomic level is also very important. So I have chosen these two material, which is known as UIO 66 and UIO 67. Okay, so in this UIO 66 and 67, we have this is made up of zinc, and this is your metal cluster. So basically in metal organic framework, you have two parts. One part is your metal cluster, another also called inorganic cluster, and another part is your organic linker. So organic linker binds this inorganic linker like you can see here. So this is your inorganic part, and this is your inorganic part. You can see, say this as inorganic cluster also. So these two, this is your cluster, this is your cluster, inorganic cluster. These inorganic cluster are bounded by uh, or jointly held by this organic linker. So this organic linker is responsible for your forming the cages. You can see here, this one cage is here, another cage is here. So these cages also you can sometimes call it as pores, and between two cages you have a window. You can see this blue ball is touching with your yellow ball. So yellow ball is just it's not an atom, it's not anything. It's just a representation to show you that this is a empty space of 12 angstrom diameter, and this is an empty space of 7.5 angstrom diameter. Okay, so this you can model all these thing on your own computer once you understand, or once you know what we need to do, or how this thing, what you want to do. Actually you can model all these things using a conventional software or any open source software. Okay, so this is UIO 66. Here you can see this is UIO 67, where the metal cluster, inorganic cluster, still remains the same, but you can see here the inorganic linker is made up of two benzene ring instead of one benzene ring. You can see over here. So here it has two benzene ring. That's why you can see a larger pores compared to this 12 angstrom, and here you have a 16 angstrom. Here you have a secondary pore, that is your 7.5 angstrom. Here you have a 12 angstrom. Okay, so in general the MOF looks like this, metal organic framework looks like this, whatever type of metal organic framework it is. Like here we are demonstrating UIO 66 and UIO 67. Now I try to understand the CO2 binding sites, or you can see CO2 more affinity, having more affinity towards inorganic linker or cluster. I try to see using a contour map, where you can see that these red zones are the highly dense area for CO2. So CO2 density is shown by the this contour map. So blue means there is no CO2, red means there are crowded, or you can say dense CO2, and green one is your less dense CO2. So this gives you a picture that what is the binding sites and what are the binding sites for CO2, where it is getting accommodated or where it is mostly no staying. Another class of material in metal organic framework which is very popular in the world, that's called the copper BTC material. It is also called as H-cast material. So this is the material looks like this, and when I have modeled this material in the computer, I try to, you can see over here, when as I said before, that whenever you model something on your computer, you need to validate your model first. So how will you validate that model? You have to validate it with the real experiment. So you can see over here, this experiment, like Chaudhary et al. Was this experiment was done within our own lab, and I have done the simulation. This work is our simulation, and this red one is the simulation of some others work. You can see how closely all these isotherm are matching or matching with each other, so overlapping with each other. So it means that our model, whatever we have prepared, that is correct, and our theoretical approach for this CO2 adsorption calculation is also correct. That's why we are able to mimic the real experimental picture. Okay, you can, this is kind of 3D contour plot where you can see one is 2D contour plot you have seen mostly, but this is kind of 3D contour plot. You can see this kind of plot. You can make this kind of plot, and you can see how this CO2 are staying. So you can see these all parts are CO2 region. Okay, these all are CO2 region. So I have tried here in copper BTC something else. So this is your linker, and this is your metal cluster, as I said before. So inorganic cluster, you can say it, or metal cluster, and this is inorganic linker. Sorry, organic linker. So I tried something else here by functionalizing this organic linker with some material that's called iodine, methyl, and dimethyl. So I have functionalized here in the hydroxyl group, not hydroxyl group, it is the CH group. Here I removed this hydrogen, and I have functionalized with iodo, methyl CH3, and dimethyl. Okay, so these data actually reveals that I have not presented here the complete adsorption isotherm which is performing better, but I can say that copper BTC iodo was performing better in terms of selectivity. So
So if I
selectivity.
may interrupt, we are running little short on time, so if you can little
Yeah.
fasten.
Yes. So another application is gas solubility in solvents. So here I have taken some green solvent. Like in industry, what happens that people use gas. People use to separate CO2 from CO2 N2 mixture by using solvent. So here I try to take some green solvent, and I have tried to calculate this solubility. You can see the selectivity of the CO2, which is like 19.4 with this solvent we got, and your experimental value is 15.5. So how we can see that how close we used to get the match, 11.3, 11.9 from the experiment. This is another application that's called denitrogenation. So here also we have done the computer simulation where we have used green solvent to separate these nitrogen impurities. Here in this experiment, this is ongoing research in our lab, which is completely experiment. Apart from what I am just discussing, that's all computational. Now this is the work which we are doing in the lab using experimental approach. So we are trying to develop some novel green solvent which can separate, or which can separate or which can recover those metals, valuable metals from your spent battery, which you use in mobile, laptop, and other electronic gadgets. So it's a very environmental concern. You cannot throw just like that in the environment, because it's very hazardous, and also that lithium reserve is also very less, and we have a lot of valuable elements inside those battery which need to be recycled to make a circular economy, or it's yeah. So here this is some of the work which we are doing on. Thank you everyone.
Thank you so much, sir, for your
I would like
wonderful.
to take question.
Yes.
If you have any question that somebody, some of you wants to do the similar kind of work in your premises, then you can always do, and you can always collaborate with me, and you can always reach to me. My email ID are there on the website. You can mail me.
Yes, sir. So it was great to have your session with us. As civil engineers, we do not sometimes we are disconnected from chemical engineering aspects. So you have very beautifully highlighted what are the latest works which are going on. May I know which software or for simulation you are using currently?
So we use a number of softwares, and we always try to work on open source software, because we don't want to be dependent on this commercial software.
Yes.
So I use Tohi, one of the software. I can write over here if audience try to pick it up. Right, Tohi for Monte Carlo. Okay. So all Monte Carlo are simulations can be done here. And another for molecular dynamic simulation, we have two softwares which is very wonderful: LAMPS and Bromax. All are open source. Okay. And for this is for molecular dynamics. I should write like this then. Dynamics. And for visualization or any kind of editing, for visualization, the very good software is VMD. And for
this is also open source, VMD.
Yeah, open source for editing any molecular editing, or you can say molecular editor. You have Avogadro.
Okay. So this visualization and editing is quite a powerful tool for us civil engineers also, because many times we have to show
powerful tool for civil engineer. As I said, one professor, I don't remember his name, but when I was doing PhD, I started with his paper only.
Yes, you were mentioning about the MIT
civil
professor.
engineer in MIT.
Correct, sir.
Yeah.
So this is really wonderful tools you have given to us, and we have given a very insightful discussion. So I hope all of our participants must have enjoyed this wonderful session. with this, as we are running short on time also, sir, we thank you once again for joining us for the conference and giving this wonderful keynote. Thank you
Thank
so
you.
much.
Thank you.
Dr. Kishan,
Yes, yes.
thank you, sir. It was really a very wonderful lecture.
Yes.
Though we as a civil engineers are exactly not working in that background, but really the applications you have shown to that material were really wonderful.
Yeah.
Because the extraction of gas is a big issue, and you are separating that carbon dioxide thing.
Yes.
That's a big application, sir.
This is
And you
one
have
of the application which we have discussed, but a civil engineering point of view, you can model many things for like those who are working on a structural part, civil engineering is
Yes.
structural. They can see the binding strength between silica and some other polymer substrate,
Correct.
right. So
absolutely,
you can
absolutely,
see those kind of thing using these tools.
Even our
definitely,
next speaker
definitely.
is an expert on steel and composites, so he'll
Yeah.
be carefully listening to you. You can enjoy his session also. Dr. Pankaj is there here.
Yes, yes,
So
yes.
with this note, let me connect to Dr. Pankaj, and maybe I will present my screen and to give his briefs to all
Thank
the
you.
participants. Yes. So we welcome now our next guest speaker. This will be our keynote session 7, Dr. Pankaj Kumar. He'll be giving his presentation on performance assessment of mechanically connected and adhesive bonded steel concrete composite connections. He is currently working as an assistant professor in the Department of Civil Engineering at NIT Nagaland. He has done his PhD and MTech from MNIT Jaipur. He is having expertise in structural engineering. His areas of interest include steel concrete composite connections, materials and RC structure behavior, durability and microstructure of concrete, and numerical and FE analysis. He is a dear friend of ours, as he has worked previously with JP University also. And we will like to heartily welcome Dr. Pankaj to give his keynote address. Over to you, sir.
Thank you. Thank you very much, Dr. Tanmay. Respected dignitaries on the dais and off the dais, team ICCMES 2024. Special thanks to Dr. Saurabh and Dr. Tanmay to invite me, dear colleague and participants present online, and might be some of you are present offline also. Very good morning to one and all. So shall we start?
Yes, sir, please. You can press maybe hide button also, so that below bar will also go away. Yes.
So in today's keynote lecture, as the Dr. Tanmay suggested, my topic is the performance evaluation of mechanically connected and adhesive bonded connection in steel concrete composite beam. Right. So these are the outline of the presentation. We will start with overview in the sense ki how we can connect these two different materials. Then in terms of material aspect, we have two different ideologically different connection methodology by which we can ensure connection between two different material and typically when I'm talking about two different material, it is the concrete and steel. So we have the mechanical connector and the adhesive bonding. Then we will look into the setup, how we can ensure the connection in between these two material. Then we will go to the material aspects, then experimental program. Later on, we will look into the performance comparison of different connection methodology deployed at the interface level and conclusion. Right. So when I'm talking about steel concrete composite, as we know, the meaning of composite is ki when we are combining two especially in the civil engineering or structural engineering, it means we are combining two or more than two different materials, right? And here we will talk about in these two materials, we will take concrete as one and steel as second material. So when we are combining them to take the best advantage of their positive attributes, then how we can ensure the connectivity between these two different material to combine them. So for that we have different connection methodology in between them, like where the first one is based upon member function, where we want to put or place that particular structural member or element. Then second one is degree of connection, the strength, how the connection or how the strength of any element out of like connected member or the connecting material is varying, and based upon that how the degree of connection will vary. Then degree of interaction, since it is all about the connection, so at the interface, how the interface is behaving, that is one of the important aspects. So there we will look into based upon stiffness of the entire or connection, the degree of interaction can be defined. Then we have different material that we will discuss with help of one experimental example. And then we will look into the characterization of connection, how based upon the loads and engendered slip behavior we can characterize the connection. Then since we know it is all about the composite means we are combining two different materials. So if we are combining two different materials, it means we have to ensure proper connection at the interface level. So when we are looking into the proper connection at the interface level, it means we have to look into the all the characteristics which are required for the particular at the interface level to ensure the proper connection or to ensure the integrity between two or to combine two or more than two different materials. So for that we have, when it is about the steel concrete composite connection, we have two different we can do push out test. So there are certain way to do the push out test. So out of them here we will look into the method which is prescribed in the Eurocode 4 or defined in Eurocode 4, that is basically a horizontal type. If we look into the similar standard of Indian that is recently revised, IS 11384, there it is some sort of horizontal. Then we will look into the full scale beam testing. So first we will look into what is the difference between composite and non-composite. So for that I took one example related to simply supported beam. So here half of the section which is the left side, that is non-composite. That if it is composite beam means at the point where we need that, we generally are getting the direct tensile stresses. At that point we put the steel, and the point or the location where we are getting compressive stresses, at that point, at that location we have taken concrete into the consideration as structural material or member. So for that, if you look into the half area, it is the concrete slab is kept over the steel, and in the second half again the concrete slab is kept over the steel beam, but there the connection at the interface is ensured with the help of mechanical connector or headed stud connector. So when we will apply any type of action over it, in that case, the apart from the deformation, since it is the in first case or in the left case, it is in this side, it is about the directly both the members are kept one over other. So in that case, we can say the rigidity is not like we cannot take the combined utilization of both the materials, so rigidity is less. Therefore, we can say rigidity is directly related to the deflection. So we will get more deflection. And if the connection at the interface level is there, in that case, we can say the entire all the materials are acting as a single unit. Therefore, we will get the rigidity is more, or combined EI composite we can use, or flexural rigidity we can use. So therefore, it is we will get lesser deflection. But apart from that deformation or deflection criteria, we will get slip. Slip is, if you look into the at the interface level, when there is no connection, it means both will deform independently. It means if based upon their position of neutral axis, they will go up and down, and based upon their depth. So therefore, we will get there is no connection, so we will get relative slip. right? And in the case of composite, when we have connection at the interface level, so through the connection only the stresses will transfer. If through the connection only stresses will transfer, it means at the interface we are, up to certain extent, we are able to restrain the slip. So therefore we will get either lesser slip, or if it is perfect connection, in that case no slip. So like as we initially discussed, we have four different connection connection methodology to ensure connection between steel and concrete. Out of them, if we are looking into based upon member function, so here we have in the first, it is about the post or column. Second one is about the composite girder or beam. Third one is an example of steel concrete composite floor system, where the steel is provided below the concrete slab in as a passive reinforcement. And last one is about the uh, composite beam column connection. So next one is degree of connection. So degree of connection is basically a strength based criteria. So when the strength of connectors is more than connected materials, likewise here we have steel and concrete, if the strength of connector is more than strength of concrete or strength of steel, in that case we can say the connection is full shear connection. It means out of all, either the steel will fail first or the concrete slab will fail first. The connection will fail at last. So therefore we can say the degree of connection is full. And when the strength of connector or the connector is lower than either steel or concrete or both, in that case we can say the connection is partial shear connection. So because the whole point is key, in that case, if the strength of connector is low, it means connector will fail first. So that is partial shear connection. Then next is degree of interaction. Interaction is basically a stiffness based criteria. Here we are looking into slip at the interface level. So here we can define the degree of interaction in three different categories. One is full interaction, second one is partial interaction, and last one is no interaction. So no interaction means ideally we like the first example where we were discussing about when both are directly placed one over other, there is no connection, that is no interaction case. And the partial interaction, whatever type of mechanical connectors we are deploying, usually because of that there is no 100% rigidity at the interface level, so connection is partial interaction. And the last one is full interaction, when we are ideally we have some rigid material at the interface level. So next one is based upon connection materials. At the material level we can take into the consideration two different connection methodologies. One is the mechanically connected and second one is adhesive bonded. So in the first figure is about the mechanical connected steel concrete composite beam, and the second one is about the adhesive bonded, which in that particular application, when it is about any structural application, we have to confirm the material must be, the characteristics of the connecting material must be confirmed from the ASTM, the particular relevant code ASTM C882, and that must be the part type 4 of adhesive. So for that we have different tests by which we can define whether the selected adhesive is structural adhesive or not. And then this next is the characterization of connection. Since we know when it is about the composite, then the main dominating criteria is how we are getting the engendered slip at the interface level and how much is the magnitude of that engendered slip at the interface level. So from there, with respect to applied loading, if there is no interfacial slip at the interfacial slip. In that case, we can say the connection is ideally rigid connection. If there is very little or very relatively lesser amount of engendered slip, in that case, connection is type of rigid connection with brittleness. If there is no post-yield behavior, if there is the relative slip, magnitude of relative slip is higher, and we are getting significant post-yield behavior, so we can say the ductility is also available and connection is semi-rigid type of. And another last, when very low stiffness is there or the relative slip at the interface is very high, then we can say connection is flexible type connection. So the difference is how there is no the criteria where we can say the connection is rigid type or connection is flexible type. So for that, there is a hypothetical limit, or we can say we have decided if at the interface level slip is more than 6 mm, in that case we can say connection is flexible, and if it is less than 6, then we can say it is semi-rigid or rigid type. So now, since the particular presentation from the or lecture from the title also depicts, we are looking into two different type of connecting materials. One is mechanically connected and second one is adhesive bonded. So before that, we have to look into what are the advantages as well as limitations for these two different type of connectors. So if we will go to the mechanical connectors, in that case, what we have, usually mechanical connectors are embedded inside the concrete. So therefore, we can say we can take the effective utilization of complete depth of material, or we can transfer the stresses effectively. Then second is, if we look into the limitations, then since like if you look into whether it is the headed stud or any type of mechanical connector that we want to connect, so of course that is connected with only a particular point or with certain cross-sectional area only. So therefore we can say that always the stress must be transferred through that area. So in that case, there must be the stress concentration available, and because of the stress concentration, we will get the shear stress distribution is not uniform. While when we will compare this with the bonded connection, in that case, what we can say, in case of bonded, since all three, there is like when we are talking about concrete, in the last case, if you look into the mechanically connected, when the connectors are embedded, in that case, there must be, you have to cast some part or complete part of concrete at the site itself. So qualities issues are there. But when we are talking about adhesive bonded, all these three um, we can cast concrete as well as we can take the hot rolled steel section as well as adhesive. All three are factory, or we can say at the workshop level, we can ensure the quality. Later on at the site, what we have to do, where the construction is ongoing, we have to put and we have to apply the adhesive at the interface, and we have to directly keep them one or other. So in that case, we can say the quality assurance is there. Then second, since it is quite visible from the figure 8 also, when we have this type of connection, in that case, there is uniform stress transfer. Why it is uniform? Because throughout the length you can bond. So throughout the length, if it is bonded, it means there is no stress concentration, and that way we can say it is ease of construction is also there. Because if we are looking into the headed connector, since there is welding, since when we are if the resources are limited, then it is the quality assurance is also difficult. When we are looking into the limitation of adhesive bonded connections, one is the durability aspect, because since it is surfacial bonding only, so durability is one of the dominating. If we can ensure the durability of connection, then only we can work on it. So since now this is on, we can say at the early stage, so therefore the durability is still, we can say, cannot say it is completely, we can ensure the lifespan of the Likewise for the RCC and other type of structures. Then surface condition. The surface condition or surface preparation is important over here to ensure the effective connection at the interface level. So as we discussed, we have at the to now, like as we know, the like when we are combining steel and concrete, steel, the properties are well defined and that we can directly get through the different type of testing, whether it is about coupon testing or anything. And for the concrete also, properties as well as stress strain behavior of the material is well defined. But what about the connection? And when the connection is deployed at the interface level, how we can ensure the connect these two material, how they will behave? So for that, the entire utilization of steel concrete composite or entire material is depends upon the connection, how the connection is deployed at the interface level. So for that, since whenever it is about the connection or when it is about the transfer of stresses from one to another, it is always the shear stress is dominating. So for that, usually we are looking into the connection performance in shear. So ideally for that, since as a civil engineer we know it is either we have to go for pull off or push out, since in the both way the connection is subjected in tension. So therefore it is whatever way you are getting better stability, that is convenient. Since as we know from the figure, it is visible, the concrete is kept in between, sorry, steel is kept in between two concrete slabs. So we can say push out was we are getting better stability in terms of experimentation. So therefore we went we did the push out test. So this is the typical arrangement of push out test. And then further to check the performance of adhesive, we have done test on full scale beam also. So this is a full scale beam setup of a 5-meter long beam, and where the different type of connection methodologies were deployed at the interface level. And from the figure also it is quite visible. There we have like the simply support ensured at at both the supports. So this is the typical figure of full scale steel concrete composite beam. Then in this particular lecture, we will discuss about how the flexural behavior of composite beam is varying when we will deploy different type of connection methodologies at the interface level. So for that, we did experiment. We did 3 different experiments, and 2 related to mechanical and connectors, and 1 related to adhesive bonding. In mechanical connector, we put 2 different connection pattern over there. One is inline pattern and another one is staggered pattern. Since we know in the steel design of steel, that is one of the basic course of steel, there we are looking into the efficiency of connection. So the efficiency of connection is again the important aspect, and here we want to check whether which one is performing better when it is about the mechanical connector, and out of 2 different, which one is performing better, right? So for that we did one experiment related to when all the connectors were placed in line. In second, we put them in a staggered pattern, and third one we took a beam of full scale size for the adhesive bonding, and we looked into 3 different criteria. One is connection capacity, second one is ultimate slip, and third one is failure mechanism. So this was the typical geometry of the concrete RCC. So for that, like we have taken like since it is about time limitation, so I didn't we compared the grade of concrete, or I can say the compressive strength of concrete with compressive strength of adhesive, so that we are getting almost same strength material. because if the strength of one material is low, since of course we cannot compare it with the steel, so but for these two, like until and unless we will not go for the same characteristic or almost same characteristic at one aspect, then we cannot say which one is performing better, because otherwise we are not taking complete utilization of the connecting material. So these are the typical dimensions for the concrete slabs in a cross section. Then for the structural steel section or beam, we took a UB of 305, 165, 46, and these are the typical geometrical details. And sorry, here we can say this is isometric view of a composite beam, where in the both side we put the roller support, and then over the support we put steel beam, and above that we casted concrete slab. So, and this is the complete view of steel concrete composite beam with headed shear stud connector. And these are the typical location of LVDTs as well as strain gauges for the experimentations. And this is the the first figure shows one inline connected headed stud connector. Second is the how we put it for the full scale beam casting, and the third one is casted specimen. And then this is the at the time of testing. Then later on, when we look into the behavior and the applied load versus engendered slip in case of the mechanically connected steel concrete composite beam, when it was reach up to the maximum load of like the ultimate, we can say the ultimate capacity of beam was roughly about 363 kilonewton with 1 mm relative slip. So here there was 3 criteria to assess the performance of composite beam like that we have selected. Of course, there are so many, but out of them, one we took as capacity, second we took as the slip, and third one we took as the deformation. Because ultimately, we can say in which case there is when we are looking into the limit state of serviceability, also the deformation is one of the important criteria, and the initial stiffness. So based upon that also we looked into it, and these are the deflections at the different level from the LVDTs. These were obtained, and this is the typical graph of taken from the different readings from the LVDT with respect to span length and deflection. However, it may come like a semi-parabolic type, but here it is linear because of the limited LVDT positions. And then it is this figure shows the typical failure in steel concrete composite beam. And then next pattern is about arranging the stud in staggered pattern. As compared in the last, the connectors were arranged in the line pattern. Now it is staggered pattern. So for that also we measured the ultimate capacity as well as the relative slip at the interface level and deformations. And in the similar pattern, we draw the deflection at the different locations and with deflection with the entire length. So for the entire length, what we did, we put all the LVDTs on one side, only the slip we took on the both the sides. And then we replicated on half of the behavior because the beam was identically, we can say, symmetric with respect to central axis. So, and then for the third case, we took a simple beam. Over that, we casted concrete slab, and then we put adhesive in between, and then we tested it. And this is the typical arrangement for the adhesive bonding. And for that also, we measured the ultimate load capacity as well as engendered slip at the interface level. So what we concluded from there, so here if we are looking into it for all 3 beam, when we are looking into the ultimate capacities we got almost same, since in the staggered pattern the capacity was little bit higher, but for the inline and adhesive, it was almost same. But when it is about the deformation, we got the significant change. That we can look over here also. We have compared initial as well as post yield stiffness, and in case of when we will compare these the mechanically connected inline and staggered, we found almost double in case of initial stiffness for uh, mechanical connected, and when we compared it with adhesive bonded, it was 10 to 15 times. So that is represented over here also. The like the elastic behavior of the composite beam start at 80% of ultimate load, and when we compare it, we found that the increase in ultimate deflection value was around 2 times. In case of mechanically connected, to be precise, it was 1.8 times for the staggered pattern and 2 times for the inline pattern. And then when we compared the stiffness, we found that adhesive bonded specimen were more stiff. So this was more initial stiffness, that was roughly about 7.89, or we can say almost 8 times of the inline connector, and almost 4.4 times the staggered connector. So that is quite high. And when we will compare post yield, that is about the ductility, or we can take it as a positive aspect also as well as negative aspect also. When we will look into the long term, or in terms of energy, it is kind of negative. The post yield adhesive bonded the stiffness was 24.50 times in case of when we will compare it with inline, and 5.65 times in case of staggered connection. The failure patterns, when we will look into the failure patterns, the mechanically headed stud connected in inline pattern, in that case we got the cracking along the both the line of connectors, and in the second case it was the longitudinal middle portion and diagonally from the center. So that is, we can say, one criteria when, like, instead of when we have the same availability of material, instead of inline, we can go for the staggered pattern. So that is all about the presentation. In case if you have any query. Thank you.
Thank you, Dr. Pankaj, for this wonderful presentation. As we understand that in today's world, we are not just limited to one material, either concrete or either steel. Composite beams are really a crucial part, and you have given a very wonderful outlook from your extensive research work which you have done with how to connect them and how to get proper strength out of this composite material. So I'll request audience members, if they have any queries, they can post it in Google Meet, or they can unmute themselves and ask the queries. Meanwhile, you can enlighten us with your current research work which you are working in NIT Nagaland.
So currently, sir, we are working on on adhesive bonded only. We are looking into the durability aspect, how we can look into the durability, since it is a new concept and still it is not the practically like only in the Russia only a few bridges they constructed for that with the adhesive bonded. So the durability is, as you know, when we are looking into any application aspect, durability is one of the challenging, and adhesive, the careful examination is needed. So
Yes.
we are planning to put it for the look into the bonding aspect and durability.
Okay. So are you trying certain new materials, certain new resins?
No, in terms of resin, since it is purely from the chemical side, so we cannot work on that aspect, since because that again we have to go into the material side.
Right.
Since we are looking into this side only, the how whatever available in market in the same aspect, like which it's on the instantaneous, or you can say the mechanical aspect, which one is perfect for us, that we will do, and we will look into 2-3 different. Now we are doing the experiment since it is on the initial stage.
Yes.
So yeah, what we are doing, we are looking into out of 3-4 or out of the selected adhesive, which one is performing better in terms of durability when we are going for different cycles.
So you are trying to do certain long-term aspects.
And long-term aspect, long-term only.
You are doing certain for creep, maybe.
Creep and continuous weathering cycle also.
Okay, both. That is a really interesting work which you have taken up, and we hope that in future we can keep on collaborating. You are already collaborating with our department, and your paper is also there, which will be presented by Dr. Kaushin. So thank you very much for presenting this very interesting topic. And I hope there's no another question from in chat box. So thank you so much, sir, for connecting with us and keeping your well wishings with us. Thank you so much. So with this, we'll move ahead to our next keynote, and which is keynote 8 for today. Let me introduce our speaker, and he's already here. We welcome you, sir. Keynote 8 will be delivered by Dr. Dev Sengupta. He is a scientist in DRDO. He'll be giving his presentation on advanced remote sensing and its application. Dr. Dev Sengupta has graduated from BHU from the Department of Geology. He completed his master's and PhD from Banaras Hindu University in the field of remote sensing and GIS. He is currently working as a scientist in DRDO. He has more than 10 years of experience in remote sensing data analysis and software-based applications. So we welcome you, sir, to our conference ICCMES 2024, and we are looking forward for your session. Over to you, sir.
Good morning, sir.
Good morning.
I'm audible, sir?
Yes, sir, very much.
Is it sharing, sir?
Not yet, sir. You can now it is coming, sir. Now it is in perfectly full screen mode, so you can.
Okay, so it is visible.
Yes, sir, it's properly visible.
Okay, thank you. And good morning to my teachers and students present over here and esteemed judges. So, out of all the presentation which has carried over here, I am working in remote sensing, so I am just presenting the simple advancement of remote sensing and their applications, and this would be helpful mostly to the students present over here. So
it will be great for our students who are waiting for this session. Thank you so much for including that topic.
So starting from the remote sensing concepts, as we know, remote sensing is the science for collecting and interpreting information on targets without being in physical contact with them. It employs electromagnetic energy in the form of radio waves, light, and heat as a means of detecting and measuring target characteristics. Remote sensing gathers information about the Earth from a distance. These are some of the remote sensing platforms we use. One is ground-based, another is aerial-based, where we use either Airbus or drones, and the last is the satellite-based. Now, coming to the components of remote sensing, first is energy source, that is sun or radar. Now, in sun, the irradiation from Earth's material, which is used in passive remote sensing. And for a radar, we are having irradiance from artificially generated energy sources, which is known as active remote sensing. Platforms, the vehicle which carries a sensor, either it can be balloon, aircraft, space shuttle, etc. Coming to sensors, device that receives electromagnetic radiation and converts it into a signal that can be recorded and displayed as either numerical data or an image. Then processing, handling remote sensed signal data, that is photographic, digital, etc. The last is the institutionalization, where organization for execution at all stages of remote sensing technology to connect space to village. This is the normal schematic map for remote sensing, how it works. Now, here A and D both can be working for energy source, Here in B, these are the radiation and the atmosphere. C, here interaction with the target, that is the Earth's surface or other topographic features. D, recording of energy by the sensor. And E, constituting transmission, reception, and processing. F, interpretation, analysis. And G is the applicative part, where we use different GIS softwares or other softwares to interpret what we have acquired from the ground. Now, coming to the basics of remote sensing, we have two major types of sensors, one for passive, another for active. Passive means the light sources of sun, and active means the light source from the sensor itself. And these are some of the examples. Passive satellite or sensors, mostly they are of optical type. And for example, Sentinel-2, ALOS, Anvil-2, Prism, Landsat series, AVHRR, MODIS, Iconos, QuickWord, Worldview, etc. Example of active sensors: Sentinel-1, ALOS Pulsar, ALOS-2, RadarSat, Tandem-X, TerraSat-X, etc. There are also some airborne sensors such as PISAR, PISAR-L2, LIDAR, etc. Recently, UAVs-based small sensors are also getting popular. These are type of sensors where passive sensors means they do not emit radiation themselves, and active sensor means they emit radiation themselves. And examples for passive sensors are multispectral sensors and hyperspectral sensors. So in multispectral, there are 2 to 10 layers, but in hyperspectral, there are more than 200 layers. Means a few bands works in multispectral sensors and a lot of bands work in hyperspectral sensors. Example for active sensors are LIDAR, radar. Okay. Now, for example, we are having hyperspectral radiometer, spectroradiometer in passive sensors. In active sensors, we are having laser, altimeter, LIDAR, radar. Now, there are types of remote sensing, which is very important. Optical remote sensing, thermal remote sensing, and microwave remote sensing. With the beginning of remote sensing, firstly, people used with optical remote sensing, and presently, the advanced remote sensing comes under microwave remote sensing and hyperspectral remote sensing of optical remote sensing. Optical remote sensing have visible near infrared, middle infrared, and short wave infrared portion of the electromagnetic spectrum, whose wavelength ranged from 300 to 3000 nanometers. They are useful for mineral exploration, lithological mapping, structural mapping, and alteration zone mapping. Specifically in hyperspectral, we go for mineral exploration and variation of mineral composition from one place to another place in a composite mine area. Coming to thermal remote sensing, as the term itself, it speaks that the thermal radiation is acquired. Now, they works from 3000 to 5000 nanometer and 8000 to 14,000 nanometer. They are very useful for fire detection, surface temperature, and thermal pollution studies. Now, coming to microwave remote sensing, they records the backscattered microwave in the wavelength range of 1 millimeter to 1 meter of electromagnetic spectrum. Example, RadarSat, SAR, synthetic aperture radar, etc. About synthetic aperture radar, we will discuss in the next slides. They are important for tectonic study, which is very important for geological perspective, and the earthquakes and other interesting problems related to civil engineering also being studied in tectonic studies. We also study regarding surface upliftment, subsidence, which is very important problem nowadays, which has the correlation with hydrology, where over extraction of water also comes into role. Then active fault zone can be discussed with SAR, or microwave remote sensing. Now this slide shows how spectra behaves. This range of colors. Now, specifically the red range, it shows unique to healthy vegetation. Green, the highest reflectance, hence we see green trees. Now, how the stacking take place between band 1, 2, and 3, giving rise to RBG. This is how we get a natural composite color. And in false color composite, we get another or fourth or fifth layers of infrared spectrum that can be near infrared or far infrared. Now, data available in different units, we are having digital number, which is the average radiance or reflectance of a smaller area. Coming to radiance, how much light the instrument sees from the object being observed. And then we come to reflectance, which compares the amount of light coming off the earth to the amount of light coming into the earth from the sun. Now, this is very important part of any remote sensing, that is the resolution. First is spatial resolution, which means it to identify the smallest possible size or object on ground. So how better the spatial resolution, higher the viewing capacity of the satellite image to minute scale. Coming to spectral resolution is the narrow wavelength range. Now here, it describes the ability of a sensor to define fine wavelength intervals, which is based on how many measuring points are within the spectral results. They are used in alteration mapping. Coming to temporal resolution, time interval between two consecutive acquisitions. Temporal means time. For instance, these two regions are of same area of different time. Coming to radiometric resolution, here same area having different satellite images with different intensity. So the difference study is done in radiometric resolution. Now, which is very important part of any satellite image, that is the difference of optical and radar remote sensing. Optical remote sensing makes use of visible, near-infrared and short-wave infrared sensors to form images of the Earth's surface by detecting the solar radiation reflected from targets on the ground. Different materials reflect and absorb differently at different wavelengths. Thus, the targets can be differentiated by the spectral reflectance signatures in the remotely sensed images. Which is very important part is optical systems are nadir looking. Nadir looking means you are looking straight away, means the satellite sensor is looking straight to ground or the point of acquisition. That is nadir looking. Now there are three types. Panchromatic, which is having single channel detector. Here, if the wavelength range coincides with the visible range, then the resulting image resembles a black and white photograph taken from space. Second is multispectral imaging system. This is a multi-channel detector. Here, each channel is sensitive to radiation within a narrow wavelength band. The resulting image is a multi-layer image which contains both the brightness and spectral or color information of the targets being observed. The last is hyperspectral imaging systems. These acquires images in about 100 or more contiguous spectral bands. Mostly, we observe more than 200. Means the starting bands which we use for hyperspectral is more than 200. The precise spectral information contained in a hyperspectral image enables better characterization and identification of targets. Coming to the radar here the radio detection and ranging full form refers to a technique as well as an instrument. The instrument name is also radar and it is also a technique. The radar instrument emits electromagnetic pulses in the radio and microwave regime and detects the reflections of these pulses from objects in its line of sight. The radar technique uses the two-way travel time of the pulse to determine the range to the detected objects and its backscattered intensity to infer physical quantities. Unlike optical, they consist of all-weather and all-day capabilities, allowing regular mapping of areas affected by heavy cloud cover, persistent rain, or extended darkness. So, here we are mostly interested in the hilly regions like Himalayan terrain, either of Himachal or Sikkim, of Arunachal, Jammu Kashmir, where use the radar satellites to understand the GLOF events or the cloud burst events or prediction of rainfall with different combination of geophysical or the glaciated areas. Radar systems are side-looking. Signal interact differently with the surface than most other sensing systems, providing interesting new information about the observed environment. This is the electromagnetic spectrum, which we know. Now, types of remote sensing images. We know about geostationary orbits directly over equator at very high altitudes that revolve in the same direction that the Earth rotates. Used in meteorological, communication, and broadcasting applications, example GEOS, Meteosat, EduSat, Galaxy 27, Kalpana 1, etc. This is Kalpana 1 is of ISRO. And polar orbit are sun synchronized. Earth resources satellites, Landsat, Spot, allows pulsar, Konos, QuickBird, etc. Types of information we gather from remote sensing: topography, soil moisture, precipitation. Okay. Field sensors, UAV, airplane, satellites. Satellite sensors, types, optical, radar, MWR, etc. Now, nadir versus oblique viewing. Nadir means straight downwards, tilted, no horizon available, visible, and high oblique means tilted horizon visible. Now, how it looks. Like these are the images when the sensor is directly on the ground, when it is slightly oblique, you can see the shifting of the images, and it's more shifting, more highly oblique. So it is an instance. Now, spectral bands commonly used in remote sensing: blue, green, red, panchromatic, near infrared, short wave infrared, medium wave, and long wave infrared, microwave region. Blue is analysis of water characteristics, water depth, and the detection of subsurface features. Green, water quality studies, measuring sediment and chlorophyll concentration. Red, discriminating vegetation types, assessing plant conditions, delineating soil and geologic boundaries, and identifying cultural features. Panchromatic. Panchromatic is very useful in image processing where image sharpening is being done using panchromatic. They are digitally combined with 2 or 3 of the multi, and these are why panchromatic is important, though it is black and white, but when it is combined with multispectral band, we get high resolution color images. Okay. Near infrared, this is useful specifically for vegetation, crop condition monitoring, biomass estimation, and soil moisture assessment. Short wave infrared, useful for analyzing micro moisture levels in soil and for monitoring plant vigor and crop condition, distinguishing clouds from snow and ice. Now, this short wave infrared is highly used in the mountainous region where we identify or we differentiate between snow and ice. Why? Like in Antarctica or other regions, snow is very brittle and very problematic. So when we work with the users of ships or when we have to land in those areas, we detect that it is the snow cover or ice cover, because mostly the ice are harder in comparison to snow. So this is very important study in that perspective. Medium wave and long wave infrared, useful to measure the temperature of features such as industrial sites. Pipelines carry heated materials, geothermal sites, and thermal pollution, also useful for the analysis of vegetation stress, soil moisture, and geology. The last is, but not the least, is the microwave region radar, useful for mapping of vegetation structures and biomass. Flooding is very important, especially in the states like Uttar Pradesh, Haryana, Bihar. Bihar is known for the flooding area of India, geological sites, etc. Now coming to radar. Radar is the most common form of imaging active microwave sensors. Radar is an acronym for radio direction and ranging, that stands for microwave and range. So here, signal is transmitted by the sensor towards the target and the backscattered signals from the objects are received back. Various target objects are distinguished from one another based on the strength of the backscattered signals. Further, the sensors also measure the time delay between the transmitted and received signals in order to determine the range or distance to the target. Now, the active microwave sensors act as a self-source which transmits a directed pattern of energy to irradiate a portion of the Earth's surface, then receives the portion scattered back to the instrument system. These are usually divided into 2 subclasses, imaging and non-imaging. The different types of non-imaging real aperture radars are scatterometer, altimeters, and meteorological radars to measure rainfall and other weather phenomena. Imaging radars can be further classified into real aperture radar, RAR, also known as side-looking aperture radar, SLAR, and synthetic aperture radar, SAR, based on the antenna size and beam width used. Now coming to RAR, it is also known as side-looking radar system that uses an antenna beam width equal to the length of the antenna. Means the inbuilt antenna size of the sensor, it is equal. Means the antenna length is smaller comparatively to SAR. RAR is an active all-weather day or night remote sensor that can be mounted on an airborne platform. Now, what is the difference between SAR and RAR? RAR is different from SAR in terms of azimuth resolution. While we are getting high resolution using SAR, that is synthetic aperture radar. They create two-dimensional images or 3D reconstructions of objects, such as landscape. SAR is typically mounted on a moving platform, such as an aircraft or spacecraft. The distance the SAR device travels over a target during the period when the target scene is illuminated creates the large synthetic antenna aperture. Synthetic means it is virtual. Virtual high distance, very long distance antenna aperture is being created. Typically, the larger the aperture, the higher the image resolution will be. This allows SAR to create high resolution images with comparatively small physical antennas. For a fixed antenna size and orientation, objects which are further away remain illuminated longer. Therefore, SAR has the property of creating larger synthetic means virtual, synthetic apertures for more distant objects, which results in a consistent spatial resolution over a range of viewing distances. Now, this is the configuration of a radar in case of SAR. Here, this is the radar antenna, where satellite. Again, here 3 to 4 satellites work at nearer to the Earth. Configuration of a radar in motion to enable synthetic aperture radar imaging. The radar antenna illuminates an area on the ground determined by its wavelength and antenna dimension. Pulses are sent and received continuously such that any point on the ground is sampled. An example of a radar imaging showing part of Isabela in the Western Galapagos Islands. This image was taken by the L-band radar in HH polarization from the space-band remote imaging radar. Now, SAR. Coming to the applicative part, environmental monitoring. SAR can be used to access and respond to climate change, ecosystem loss, and natural disasters. Agriculture. SAR can help farmers monitor crops, detect plant diseases, and optimize irrigation strategies. Disaster management. SAR can provide rapid and accurate information during events like earthquakes, floods, and landslides. For DRDO perspective, we are more interested that SAR can be used for the military purposes, where we get the target acquisition and tracking, providing detailed images of enemy targets, buildings, vehicle, and even camouflaged or hidden objects. As the SAR, that the microwaves, they can penetrate the Earth's surface to some centimeters to meter. Wildfire risk assessment. SAR can be used to predict wildfires by analyzing soil moisture measurement and land classifications. Earth resource mapping. SAR can be used for mapping Earth resources. Mineral exploration. SAR can be used for mineral exploration. Oil spill boundaries. SAR can be used to track the movement of oil spills onto coastal areas. Sea state and ice hazard maps. SAR can be used to create maps of sea state and ice hazards. SAR systems use radar signals and digital electronics to provide high-resolution imageries. Now, SAR can be used to monitor land subsidence. Presently, for the students here or the scholars who are working in India or abroad, but not with the border regions. Specifically, land subsidence problem is dedicated to the overpopulated metropolitan cities and to the coastal regions. How that SAR can easily monitor that how much groundwater is being depleted, and due to that, due to the overburden pressure, the subsidence, land subsidence is taking place. And another important aspect is when there is land subsidence in coastal region, we are losing land. This is very important problem. There are some important publications in Nature that in USA, USA has lost around 3 to 4 centimeters of land throughout the oceanic border, which so SAR helps with infrastructural planning and risk assessment. These are the risks. Here are some applications of SAR data for land site subsidence. Urban planning. SAR can help cities plan for sustainable growth by detecting subsidence in urban areas and assessing the structural health of buildings and infrastructure. Groundwater extraction. SAR can help authorities understand the surface effects of groundwater extraction and its potential impact on infrastructure. Risk assessment. SAR can help with risk assessment related to subsidence. Most SAR instruments are limited to only sensing in one wavelength at any time. There are 5 wavelength bands used in current and upcoming radar land surfaces imaging satellite systems. P band, they have the wavelength penetration up to 65 centimeter. L bands 23.5 centimeter penetration ability. S band 9.4 centimeter, C 5.6 centimeter, X band 3.1 centimeter. Typically, these signals will mainly reflect off objects of similar size or larger than their wavelengths, allowing for different properties to be observed by different wavelengths. Now, depending on the observation targets, different bands have different strengths and weaknesses. For example, longer bands such as L and P bands are capable of providing information on the below canopy structures of forest. In case of huge forest studies, these bands are used, but are less sensitive to grasses and low vegetation. Means when we go for SAR, we use this L and P bands for dense and huge trees covered forest area. But the regions like savannas or grasslands, we use like S bands, C bands, or X bands. Okay. Shorter bands, on the other hand, are more useful for imagery of grasslands, savannas, croplands, and pasturelands. In combination, but if there is a combination of area where we have huge trees, including grasslands, then imagery in these bands, like combination of all, can be used for substantial amount of information about the earth and its processes.
Sir, if I may
Yes.
interrupt, we are running a little bit late on
Yes,
time.
sir. I'm just going to complete.
Sure.
SAR uses a band of the microwave spectrum known as the L band. Now, these are the last slides where breach monitoring has been done. The true potential of SAR technique results from combining multiple imaging cover the same area. Okay, worked by PG and CR Middleton in 2022. Here, individual SAR images typically cover areas of hundreds of kilometers, so that there is a potential for large number of structures to be monitored at low cost per structure. Another study for land subsidence, the declining water levels have the potential to induce or renew land subsidence. Using SAR, we can do effective change of land surface. The type and density of ground cover also can significantly affect interferogram quality. Densely forested areas are prone to reflect poor signals. There are different case studies. I will not go in detail. And these are some of the recent studies in abroad and also in India, and specifically of Varanasi, where land subsidence is a major problem, which can be easily monitored and predicted using SAR. Thank you.
So thank you so much, sir, for quickly wrapping the last few slides and giving the students a wonderful opportunity to understand advances in remote sensing and how crucial it is and how multifaceted it is. Its application is really very wide spectrum. So you have very in depth, you have told about the various techniques which are available. So I invite any questions from participants. If they are there, you can either put in Google Meet box, or you can directly open your mic and ask your question out loud. So if there are no further questions from participants, we'd like to give our hearty thanks to Dr. Sengupta. Okay, Ayush has one question. So question is, sir, where can we find historical optional data, optical data for 1994?
Yeah, actually, this is a big problem because whatever the remote sensing we have used, or the sensor satellite data, they are mostly after means more specific and good data along 90s or after 90s. Means the more advancement came after 2000. So we have to use previous topographic sheets and all this.
So I hope this answers. Ayush, to you, if you have any further query, you can comment on it. One more question is, how SAR helps in detecting groundwater level?
Yeah, this is very interesting question, because SAR has the tendency to understand because the waves, they get inside the land and they can monitor the time series of depletion of groundwater. Okay, so with that we go for land subsidence. So this is a somewhat of time series studies for a long time, like for 2 to 3 years. After on that basis, we understand that the more and more groundwater depletion and creation of voids, empty voids below subsurface, they can be understood by the microwave remote sensing in SAR.
Yes, sir. So this very wonderfully answers.
Thank you, sir, for this information.
Thank you, sir. Thank you, sir. Most welcome.
So with this, we come to an end to our keynote session 8, which was a delight for our students as well as other scholars and faculty members to gain an experience in remote sensing and understand the advances which have been made. So with this, we'll have a break in our keynote sessions for now, and we'll be joining back our keynote sessions at 2:30. Which will be our last keynote for the conference, keynote number 9, which will be delivered by Dr. Harinayan Tiwari, and is scheduled from 2:30 p.m. So I'll request all the participants to tune in at 2:30 to not miss